record a new lecture. So today we will talk about context. So we will continue the discussion on values in context and why we use it and where, how it works a little bit more. And then we will come back to pragmatic aspects and to debugging, how we do debugging in Haskell, okay? Any questions about the first part, about the setup and stack? Who has used stack before? Yeah, good. So those people who didn't, I strongly encourage you to start. It's much easier. It makes like project management and compilation cycle and so on kind of easier. All right, that deadline is moved, so I will move it to 21st, and we talk about context. So what is the challenge? The challenge is, as we discussed last week, that sometimes our happy path fails and we have to deal with the unhappy path, right? So we usually have some sort of mechanism for dealing with the happy and unhappy path. And in the happy path, we have to wrap the values in some sort of context. Like the context decides if we are on the happy or unhappy path, right? That's our context. The context contains this information that says, okay, what you're doing right now is on the happy path, or what you're doing right now is on the unhappy path, right? That's what we had with maybe. But we also have in other contexts, like a list is a context. So we have values in the list, but the list creates the context for our values, that they are inside the list, right? So if you want to do something on the value, you cannot use a normal function. You have to use something that knows how to do it, right? So like if we go, let's go to GHCI and then say I have a number, but if I have number and it is 10, I can use a normal function and I can say plus 23 to my number. I can do that, right? I'm applying a function to my number and it gives me a result. But if my number is in a context and the context is a list, right? So now my number is inside a list and I try to do that. What's going to happen? I will have an error. It will say, yeah, you cannot say 10 plus what was the number 23? You cannot do that, right? I cannot do that. I can do a number without a context, that's fine, but number inside a context, I cannot. But what if I want to do that? What if I want to add 23 to the number in my context? Okay, so we learned that we have to use some tricks. We have to use some operators. So if I have my plus 23 function, we learned that we can fmap it, right? We can fmap it to, to something in the context. Why it does not work? Yeah, it does not work because fmap is not the, like to use it this way, I would have to say it's in the middle, right? Then it works because fmap is not the operator that normally works in the middle. It's the operator which takes the first argument, which is the function, and then something with the context and applies the function to something in the context, right? So we learned about that. And we learned that fmap is an example of functor, right? And if the context is a list, it can be used just map. It is the same. Fmap is map, right? We also learned that there is a shortcut for this middle infix notation. So I can do this, and it will be the same. So this and fmap and map for lists are all the same, right? So if you ask, okay, what is the type of this? It will tell you, yeah, it's the function which like this function takes this as a first argument and this as a second argument and gives you this as a result. And then if we do the same for fmap, you will see it's exactly the same, right? This line and this line are the same. But there is a small difference. So if I ask about fmap, it says, yeah, it's this function. And if I ask about this one, it says it's an infix operator. So it's in the middle, like plus, right? Plus can be used like I can use plus in the beginning and say do 23 plus 10. But I can also say plus in as an infix operator, right? It is both. But with the dollar sign in brackets, it's only the infix. It's only kind of in the middle, right? But fmap is not. But we can turn fmap into the middle operator by those ticks, right? So it's all about syntax, but not that interesting. The interesting thing that we have functions which we want to apply to values in some context. And then simple function application does not work, right? So that's why we having those machinery which allows us to do something on values inside the context, right? So then we learned about functor, and we learned that we can map a function over a value in a context. So we have fmap and as a prefix operator as like a function, or the infix operator like in the middle, and it takes a function, the value in the context, and produces a new value in the context based on this function, right? Is it easy for you to read this notation already or not quite yet? Yeah. You just have to spend some time like staring at it and like trying to read it. Once you get familiar with reading it, it's like really like there is not a lot of extra characters that are needed. So it's quite good. Anyway, applicatives. So applicative let us apply a wrapped function to a wrapped value, right? So again, we discussed this before. So we said, okay, I know now how to do my how to apply a function to a value inside the context. But this does not work if my function is inside the context as well, right? So now I have a function in the context and a value in the context, and this does not work. This will produce a problem, right? So then we learned, okay, you can apply it if you use the apply operator, and the apply operator is this symbol with a star, and then it will work, right? So applicatives allow us to apply a function in the context to something in the context. And we have this apply operator, and the type signature is similar to functor, but remember in the functor, there was no f here. It was a normal function to a with the functor value to a functor value. But here it's the value in f to a function in f to a value in f to the new value in f, right? So everything is in the context. We have context for the function, we have context for the argument, and we have a context for the result. So as an example, we have just plus 3 applied to just 5, and then this function is applied to this value, and it leaves kind of a new value inside the context, right? So it's useful for applying functions with multiple arguments in the context. There is a typo. Let me just quickly fix. Yeah, I have to go here for a second. All right. There is a question in the chat. Short break. I guess so. So let's have a break after the. Let's have a break now. So let's do the break. How much time? 5 minutes? All right, 5 minutes. Resume the recording for the lecture. So again, very quick recall. Normal function, value in the box. function in the box, value in the box. So write a function that adds two maybe ints. So the normal function for adding numbers is plus, but the plus will not work for maybe ints, right? So write a function which will add two numbers, which are inside a context, inside a maybe. So think about it and do it. I will do it here as well. So I go to Haskell lectures. I will say stack. I will follow the process which we just did. Stack new lecture 05. I will open the code. Oops, not this one. I will go inside. I will vim stack YAML. So I will change this to my compiler, to the nightly 250307. So I'm doing that change. I'm also doing the change for the doc tests. So I will open package YAML, and we'll change that we are using dependencies for the tests, and I want to use doc tests. Doc test, yep. Then I will open it. In source, I will say add maybe, and then we don't need this function. And then in the declaration, we say adds two numbers inside the maybe box. Okay. And then I will make some tests. Perfect. 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 And one more. Yeah, that one is fine too. So code completion is very friendly for doing tests, and now I have to declare it. So that's what the Copilot suggests. Do we like that implementation? So Copilot says, do this. If I do this, I have to do this also, right? So if I did what it suggested, I have to do this as well. Otherwise, the function would not be total, would not be completed, because there is a pattern matching on the first argument or on the second argument. But what if one of those is nothing, right? Then my declaration is not complete. So then I have to write two lines, right? Writing two lines for this is overkill. It's like too much work, way too much work. We don't want that. So what we do? So we have X and Y and Y. X and Y for the parameters, and then this will not work, right? So we know plus will not work, right? But what else do we know? What would work? If we do plus, and if we apply it, right? But we have to build a function first. So we have to build a function which will be in the context and then take one argument in the context. So then apply will work for us. So we like this will not work yet because plus x is not in the context, and also plus cannot be applied to x directly yet because x is in the context, right? You getting it? Let's try things out in the so if we go to GHCI, we have x which is just 3 and y which is just 10. Okay, we want to add them. So if we say x plus y, it's not gonna work. If we say plus x plus x with y, that's not gonna work neither because we are missing something. Like this is a normal function and the value in the context. What can we do? Can we apply a function to a value in the context? Yes, we can, because we know it's a functor, right? We can kind of apply a normal function to a value in the context, and we can do that by doing this. So now let me ask, what is this? Okay, it's a function which takes a maybe value. We like it is like this is a box which contains a function which takes a normal value and produces a normal value. So it's a function, normal function in a box, right? This gives us a normal function in a box, which is great. That's what we need. So we have a function in a box applied to a value in a box, right? Let's test it. So if I have y, I don't ask what it is. I just want to do it. I get just 13, right? So this will work. So then I will save it. I will go to my tests and I will say I want to import tests doc test, and then here I don't want this. I want doc tests. Yeah, I want this, but I don't want this. I want app main. That's what I want. So then if I go to my project and say stack run, in the main, what are we doing in the main? We're not doing anything in the main yet, right? No, we're not doing anything. So adding two numbers. Yeah, let's do so I want to print that number which is in the box. How can I print a number which is in the box? So put string line is a function which needs a string, but I will have, let's say, I have v, which is this, right? So v is just 3. So I have to get it. Like how can I do that? This is a normal function, and it has to be applied into a value in the box, right? So we have to do this. And we have to convert the number because this function takes a string. So we have to convert it to the number from V to we want to do this. Okay, let's test this. Stack run. Yeah, so we did some nightly snapshot. We cannot have spaces here. So it has to be without space. Okay. And then it complains. Mismatch brackets, possibly mismatch brackets in lib line 23. All right. Lib, what? Yeah, lib 23. Right. So lib 23. I don't have any. Yeah, I forgot to add this y value. Okay. So then we go back and we run it. And it says, I don't know what is V. Yeah, fine, fair enough. So we want to make it where V is this, obviously. Usually we do it in multi-line, so we usually do this. And then it says main. It does not like the type which we are getting out of this because main should return an IO action with like an empty tuple, and we are getting an IO with the box which our V is in because put string line will put whatever is printing into a box, but we are already in the box. We are already operating on the box, which is the value of the maybe type, right? So let's not dive too much into this yet. We just say hello for now because we have like two boxes. And I don't want to talk about two boxes yet. So it works, it prints hello, and then if I say stack test, it will first build all the dependencies, and then it is running 5 tests and tried 5 tests, and there was 0 failures. Usually it's good practice to check how many tests you have. So we have 1, 2, 3, 4, 5. So it tests all the tests, right? So it's fine. Sometimes if you're missing this bar or if you're missing a space or something, some functions may not pick up the doc tests, and then you like think everything works, but the doc test is not parsing them correctly. So it's usually kind of a sanity check to count how many you have. And then if you're adding some, like this result here should match your expectation, right? If this says you have 0 examples, that means no of your doc tests are being tested, right? All right, so who understands this function? Who understands how it works? Who understands that first part? Nobody? That's not good. So if I write it here, that I have a function plus, and I have a value in the box. I have a value 10. I have, let's say, 23, right? So my f is this. This is my normal function. I can say f to 10, and what will be the result? Yeah? 33. Excellent. How many arguments f takes? 1. Perfect. And it is a normal function, right? So then I have f, and I have a box. Who understands this? You know it from other programming languages, right? You can map function over values of the array, right? So what is happening here? This normal function is being passed this parameter from inside the box. It's doing the thing, and whatever the result is put back into a box, right? So f adds 23 to whatever it is passed. It is passed 10 because map takes this value out of the box, gives it to that function calculates 23, and then map puts it back into the same box, right? So who understands this? Perfect. So then how about just 10? We have a different box, but the mechanism is exactly the same, right? We take the value out of the box, apply the function to it, and put it back into a box, right? Will it work? No, it will not work because we have to use fmap. It's the slightly different map, but it's the same concept, right? So now it will work, and we'll just get the box with the new value, right, inside. So far so good. We are clear on that, right? Good. So then I can replace fmap with this infix operator, which is exactly like fmap. It's just the infix form. Fmap and this guy is exactly the same thing, right? It's just that you use it in between as an infix. We get exactly the same result. Simple so far? Yeah. All right, great. So now we have small complication. Our f is composed of plus and a value, right? So we have a plus function, which takes 2 arguments and a value, right? So how we did f? We said, okay, apply plus to 23, right? So we're sort of doing like kind of like 23 plus, and then this missing argument is the argument to our f, right? That's what we did here. We said f is kind of like 23 plus, and the missing argument needs to be passed to f, right? So we constructed a new function by applying it to an argument, but there is one argument missing, right? So the argument is missing, but we got kind of a function with one argument already in it, right? Is that clear as well? Right. So now I have a function which is plus, and I want to do the same. I want to get f, but this time I have a value in a box. So I have a 2-argument function, and I have a value in a box. Let's say a box is a familiar box of list, right? So now what I would like to get is I would like to get, yeah, not 10, 23. I want to get plus 23 inside the box. So I have a normal function. This function takes 2 arguments, but we don't care. We only gonna give it 1 argument. That's what we did to f. We only gave plus 1 argument, right? And then we got f. I want to do the same. I want to get plus, give it 1 argument, but unfortunately, this argument is inside a box, right? And then I want to get this plus 23 inside the box. So how I'm gonna do that? Well, any suggestions? Will map work? It will work. So it works. It's just the GHCI doesn't know how to show it. Okay, I can prove to you that it works. I can say the new F list is equal to this, and then I can ask what is the type of F list, and it tells me, well, it's a list. It's a list of functions from number to number, right? Which is true, yeah?
This box, you said box, but it's a list. It's just what?
It's this context. It's some form of context, right? So a list can give your numbers a context that this number is inside a list, right? So there is a difference between number which is like 10 and number which is inside a list. Correct? This and this are two different things, but 10 is exactly the same. This 10 is exactly the same as this 10, right? Yeah?
How would you get something out of a box? Just the box in your examples are complete with different data structures. Like,
Yeah, they are. Yeah. So, like, how we get 10 out of the list? We say, give me the first element of that list, and it will be 10, right? So that's how you get the value out. If you say, I have just 10, there is a from just, and it gives me 10. So you can always get a value out of the box and get the raw value, what it is, right? But in these examples, we don't want to get the value out. We want to do something on the value inside the box. And the result is also inside the box. So we're not taking it out, doing something and putting it back. It actually happens inside the box, right? Good questions. So the box is some form of context of values that are in that context. In a context of the list is the list itself, right? But it could be also like the context, which is maybe like just, right? So this number is just a normal integer, same as this one. But if I want, like this number has the box, like there is a box and the number is inside the box. And I cannot say just I cannot do this. I cannot say just 10 plus just 23, right? I cannot do that. And I cannot do that with this neither. I cannot write code like this, right? I cannot do that neither. But I can add 10 to 23. Those are just integers. I can add them together. To add them together, I need a normal function. But to add those values in the boxes, I cannot use normal function. I have to use this functor or applicative to be able to do this addition, right? So I have to put my addition into the context of this box, right? So if I do this, if I have plus inside a box and I have a first value and the second value, I can apply them in a chain. So I can do this. And then I'm gonna get the result, right? So now my plus is inside the box. My first value and the second value are inside the box. And I can kind of get the addition being done on the values inside the boxes. And the result is in the box as well. What will this produce? Yeah?
the list with plus 10 function.
Exactly. It will produce a list with a single element, and the element will be a function plus 10, right? I cannot display it here. So GHCI, the like interactive interpreter, cannot display functions. Like it cannot display. So if I set plus 10, let's use this 23 for consistency. So I have to use the brackets. So then f is a single argument function, which is 23. But if I say show me f, it does not know how to show me what f is. But f is a function, right? So every time you get a show error in the interpreter, that means the structure is correct. Just the interpreter cannot show it to you, right? So coming back to this, that would produce a box with the single argument function inside. And then I have a second box with the single value. So then I can, so if my f is this, so this is f inside the box. That's a bad name. Let's do this. So this is my f inside box. And then if I say f inside box, do apply yourself to a value inside the box, then it will work, right? It will produce the new value. That was plus 10 inside the box, and then it's this one. So coming back to the original question, what would this one do? What will this function do? Same thing, right? It would produce a list with a plus 23 inside. So a list with a single element. So I can also do fmap. And it's the same, exactly the same. And I can also do this. And it's also exactly the same, right? So now I have a box with a function which takes one argument. So then I can chain it with a value inside a box. And it will produce 33. So now do you get it? Or still not? Yep. You get it? So x is maybe int. The int is inside the maybe box. We have a plus. We want to produce this plus int function. So we have to map first, fmap first, that normal function to the value inside the box. And then we will get the function inside the box. And then we apply this function inside the box to the second value. So who understands it now? Some success. All right, so then I think others will have to play a little bit more with GHCI and get kind of the intuition, right? Yeah? Yeah, we call plus an operator, right? Plus is an addition operator. And we the same called those things, those symbols, operators. And this symbol is called fmap because it does exactly the same as fmap. It's just the infix notation for fmap, right? So it's like fmap or map. And this one is called apply. So we say apply this function to this value, but this function is in the box.
So like the general concept of brackets or not the alligator brackets does not have a name?
No, there is no special meaning about the angle brackets.
Have we figure out what functions we can have inside of the, if we can search out the concepts?
No, so the brackets, the square brackets and the dollar sign and the multiplication sign are treated as normal characters, and you can define your functions using those characters. So those are just normal functions. So plus is a normal function, and those things are normal functions. And you can define, let me say we have fancy and then equals something. And that is your function. Like you can declare, you can use it as a normal character. It has no special meaning.
Yeah, I thought it was like those were wrapping.
No. They are not wrapping anything. Those Those symbols are just normal characters. The round brackets are for like in other programming languages, they have meaning that you're wrapping something inside. But the square brackets and those brackets, like the square brackets are for lists, and that the less than, more than signs, they have no meaning whatsoever. You can use them in your own functions if you want to. And many people declare like some fancy names, and they basically mean they will use infix notation. So by convenience, all those functions which are in those brackets, they usually are infix notation, and they do some kind of transformations for you. Yeah.
To find the infix version of a function, because you said like fmap, how would we find this infix version of it?
Yeah, that's a good question. I don't think you can easily find it. Let me try. If we go to Google, usually what you can do is you can search for functions which have a certain signature, right? So what we can do is we can go to this guy and say, what is the type of fmap? And then it tells us this is the type. So if we copy the whole type and say, search me for functions which have that type, you see, it tells you fmap has this type, and this one has also this type, right? So you will kind of find that this symbol is exactly the same as fmap by asking about the type. So then you may be able to find, if you know the prefix function and you ask what is the type of that, like find me all the functions with that type for the prefix version, it will probably find you the infix version, like using Google. Yeah. Okay, so we spent quite a long time here, and that's the answer. And then we cheated here because we don't use put string line, we use print. And print is a little bit nicer, so I will show you here. So if we ask what is the type of print, print basically converts a value which can be converted to a string. So it has the show meta class declared into a IO action. We didn't talk much about IO yet, so again, I'm not gonna dive too much into this. I just tell you that print is like simpler to use, and then put string line is a little bit harder to use because it requires a string, and it has to, yeah, it's kind of similar. It also generates IO action. So the thing is that, as you see, print will convert it to the just 15, like to the box. So it kind of eats up our maybe monad. So where do we use applicatives? We use applicatives a lot for form validation, for parsing things, for writing parsers, and sometimes for writing small interpreters, and for combining multiple effects in parallel. So if we want to do kind of parallel processing, applicatives are extremely powerful because you can kind of chain them, and each step can be done kind of independently, right? They have one problem. So the problem is that if you have the box, so we say the context, right? So we say you have a context and you have a value in the context. And then the context, how can I show you this so you get the intuition? Look at this. I have a value in the box, which is just 23, okay? That's one value in the box. So there is a box with a value inside, right? Okay, then let's call it A. Okay, and then I have another box, and this box is just 10. So then I have A and B, and then I'm doing something with them, and I'm combining them. So let's say I'm passing, so then I have this plus function. So I have just plus combined with A, and then combined with B. So the left-hand side argument to the plus will be A, and the right-hand side argument will be B. So far, so good, right? And then the result is a new value in a box, right? Because the plus will do this, correct? So I will get just 33. But what if my first box, is nothing, right? So I have nothing being tried to be added to some number, and that's gonna fail, right? So I have an unhappy path. So part of my arguments is on unhappy path, and part of the argument is on the happy path, right? So then, if this is the case, what's this gonna give me? It's gonna give me nothing, right? Because we are on the unhappy path. But I have no information in this context that I had a value in the happy context. The context is lost. Like, so when we combining two things in two boxes and we producing the final box has nothing to do with the boxes which were before. The context cannot be carried over. So it's kind of stateless, right? You will get the intuition once we get to monads, because in monads, you have the same thing, but you can carry additional state from the boxes such that the final box knows what has happened in the previous boxes. It's like the context kind of is chained, and the context is not created kind of fresh, but here it is, right? So here there's nothing, is just like an empty box, which cannot carry from me anything about what the boxes had before. It just tells me, yep, you are on unhappy path. That's it. That's all I know, right? I cannot carry additional sort of information. So this is where Applicatives shines, but there is this missing element where you want to carry a state of something from one box to another, from one context to the next context. You want the context to be stable. You don't want to kind of create completely new context every time you're applying those functions kind of in the middle, right? So then you have to use monads. And monads are for sequencing, for combining dependent computation. That's what we do often in imperative programming. We have a state, and we kind of manipulate that state through multiple functions, through multiple operations. So it allows the computations to depend on the previous state, right? So with the applicatives, we basically have happy path, unhappy path. If you're on happy path, you're doing one thing. If you are on unhappy path, you're doing one thing, right? But monads allow you to say, okay, you are on a path, and that path can be in the unhappy family, but it can be only on the happy family, but it has multiple states, it has multiple options. And then you will pick the one based on the state that you are in, right? It's more nuanced, it carries that additional information of what is inside the context. The context for applicative is very trivial. It's very yeah, it's much simpler because it does not depend on the previous state. You basically, like in the case of maybe, you have two boxes. You have an empty box and a box with a value, and then the result is either a box with the value or an empty box. And it's a new box, like it has nothing to do with those two boxes. It's like a new box which is either empty or with a value. But in monad, you have a box, and you're doing something in the box, and it is the same box in the new value. And then you're doing something in the box, and it's the same box. And the box itself can carry a certain state, right? So when you're producing something as a result, you can carry what has happened before, such that the box is the same box with an extra state. It's like you can kind of write on the box what you want, like it's additional stateful information that you carry through. So it's for like monads extend applicatives, and they allow the new computation depend on what has happened before. And the key operator is bind. So this is a bind operator. It is an infix operator, and as you can realize, it doesn't use the brackets on the outside, and it has this signature. So it's kind of the bind operator is the other way around. We take the monadic value and then we bind it to a monadic function to get a new monadic value. So this is monadic value. This is a monadic function which takes a normal value and produces monadic value. And this is a monadic outcome, monadic value at the end. And then it's useful to think about it as chaining. So I basically have some state that I'm kind of doing initially, and then I'm doing something more on it, and more on it, and more on it, and more on it, and then at the end, I am done. But the state, like it's contained to the monad. It cannot go outside of the monad. So it doesn't have any side effects. It's like contained to that monad which I'm carrying over, right? All right, so here is an example where we are trying to make a safe division, right? So it's very similar to the previous case where we were doing kind of, we had two values in a box and we are doing addition. Now we have two values in the box and we're doing division, right? We could use applicative for it. We could say, if I try to divide by 0, I get nothing at the end, right? You could do that. And it's the same here. We basically saying I have a maybe int and produce maybe int. And instead of applicative, I'm using the bind, which says, okay, get me the first argument, the first number, and bind it to that function, which says, give me the second argument, and then do this safe division. And the safe division is using this diff, which is the prefix operator, but it treats it as an infix, and it basically divides x with y. And then for 0, it produces nothing, but if the argument is not 0, it produces a result, right? So we catch division by 0 by producing nothing, and then we produce a value in a box if it's a normal box, right? So again, we have a happy path, unhappy path, and then we are calculating it using the monadic structure. You may ask, okay, Mariusz, so what sort of state you carrying over from the first monadic box to the second one to the last one? And the answer is none, because maybe is applicative. So maybe monad is also an applicative, and it does not carry extra state through the creation of boxes, right? So in this particular case, it makes no sense to do a monad because you don't gain anything. It's exactly the same as if you use applicative, right? But with some monads, you do. So where the monads shine, with input-output, with state management, anytime you have some sort of state to carry about, which is often, like, we program and we have to deal with state. For error handling, to propagate the error and decide what to do later. So you kind of not saying, okay, I'm in an unhappy path and that's it. Like with error handling, you can sort of have a more nuanced pathways saying, okay, I'm kind of, I didn't achieve what I wanted, but I can do this instead. So you have kind of a more nuanced handling of errors. And then for asynchronous programming. All right, so I have to stop. I have one question. Let me see. Yeah, so there is a suggestion to do with boxes which contain multiple things, like, for example, multiple values in a list, and that is also possible. So if I say my A is 3 values, 1, 2, and 3, and then B is 3 values. Let's pick 100, 200, and 300. and then I am doing the same thing as I was doing before, we're gonna get all possible permutations for applying. Yeah, I cannot do this because I'm using a different boxing metaphor. So I have a first box which has one argument, one element. Then I have a second box that has three, and third one which also has three, right? So then if we do that, we're gonna end up with the generation of the three partial functions. And the three partial functions are gonna get applied to the three values 100, 200, and 300, right? So the partial functions are +1, +2, +3, right? And then we have three values. So we end up with +1, +2, and +3 to three values, which is 100, 200, and 300, right? So you get the kind of computation. So for arrays, it's very nice because I don't need any loops, right? How many loops would you need to do, like an imperative programming, to do this type of computation? You would need to use three loops. The first one to produce the functions for plus what, plus what, plus what, and then for the first argument, and then for the second argument, right? So like two inner, like one outer and one inner loop. But here it can be done like by sequencing what needs to happen, right? It's a little bit difficult to think this way because we tend to think in loops. It's easier kind of to think like in a loop. But once you tried it a few times and you have this situation where you have to iterate over, let's say, two arrays, then you say, okay, those are lists. I can do this instead, right? And then you write a one-liner. So that was one question from the chat. Right, I have to stop here, so we will continue. I have about 10 minutes, maybe 15 minutes to close this with some questions. Do you want to be done after the break? So I will just count how many slides I have. Let me see. No, it's longer. It is longer. Yeah, it's like 20 slides. No, we have to move it. So this is still about the context, and then I have the debugging part. So let's do this. Let me move the context discussion for the next lecture, and then after the break, I will talk for like maybe 5 minutes about how you do debugging in Haskell, okay? So some of you may benefit from knowing how to do debugging in Haskell, even though I kind of strongly discourage you doing the debugging in Haskell, but I can show you how to do it, and that might be useful. So let's kind of cut it here, and then I will come back to this next time. And now let's have a break.